So again, we want to connect this idea that percent, fractions, rates, ratios, they're all essentially the same thing. They're all a ratio comparing two things. So when we have a decimal 0.25, we can put it into a rate. So we can put it all sorts of rates. We can put it into a rate of 1 to 5, or sorry, 1 to 4. And as a rate, we need to actually compare two things. Okay, so in this case, we can say 1 orange, or $1 for 4 oranges. Okay, so that's a whole number rate. We can do this as a decimal rate. We can say $0.25 per 1 orange. Okay, now this is something that I want you to make up something, a rate that makes sense for yourself. Okay, so you can do it as a decimal rate, you can do it as a whole number rate. Okay, I'm going to leave this as $0.25 per orange. As a fraction, this is going to be 1 over 4. As a percentage, we can convert that to 25%. As a ratio, we can keep it as a ratio to 1, 0.25 to 1. But as a ratio, we can, just like with the rate, we don't have to keep it as a unit ratio. We can do a whole number ratio. Okay, we can do 4 to 1. Okay, for this one here, $3.30 per 6 bagels, I'm just going to convert that to decimal by dividing. And when I divide, I essentially get my unit rate. So again, notice that my unit rate up here, this was found by division. I just kept that divide. If I can divide 1 over 4, I get that unit rate. So in this case, I'm just going to do $3.30 divided by 6 bagels, and I get 0.55 as my decimal. Okay, so 0.55. That also represents my unit rate. So that is 0.55 dollars per 1 bagel. Okay, as a fraction, I probably want to show this as 330 over 600. Okay, so I want to increase that, get rid of the decimals there, because as fraction, it's implied we don't have decimals, although this does share common factors. Okay, so if I divide by 30, I end up with 11 over 20. Okay, so as a percentage, the decimal and the percentage kind of go together, so we know that that's going to be 55%, or we're going to have 55% of $1 per 1 bagel. And as a ratio, I'm going to keep this as a unit ratio, so 50.55 to 1. So here, the fraction, we can write this as a percentage. Actually, let's convert that to decimal first. When we divide, we're going to get 0.77 repeating. So I'm going to round that to 0.78. Okay, convert that to percentage, 77. I'm going to use a couple decimals here, so 0.78%. As a ratio, we can just write this as, keep the same ratio as a fraction. And as a rate, again, you just come up with any rate you want. Okay, in this case, I'm going to buy 7 liters of milk. For $9. Okay, so that's my rate. And I can change this into a unit rate by dividing. It's going to end up being 78.78 liters of milk per dollar. Okay, so here we have a rate problem. So we have Tour de France. It's traveling, this 2007 Tour de France. We travel 3,550 kilometers, and the winning time was 91 hours. So the winning time as a ratio is going to be 3,550 kilometers per 91 hours. Okay, and we could write this as a ratio like this, we can also write this as a unit rate. Okay, so I'm going to actually write the rate as a unit rate. So we could write this as 3550 kilometers per 91 hours as a rate like that. But we're going to convert this into a unit rate. And the unit rate's a bit more familiar to us because it's going to be kilometers per hour. So 3550 divided by 91 is 39.01 kilometers per hour. 39.01 kilometers per 1 hour. It's still a rate. We still have a ratio of comparison here. But now this is a rate that's much more familiar to us. So these guys were riding at an average rate of 39.01 kilometers per hour for the whole entire race. So in 2004, Ichiro Suzuki, who's the all-time greatest player ever, in my opinion anyways, he had 262 hits in 704 at bats. So he got that many hits, and he had 704 attempts at it. So let's write this as a fraction and reduce this fraction. So 262 over 704. Okay, we need to reduce this fraction, so we need to find some common factors. Okay, so 262 and 704 share a common factor of 2. And I think that's it. So when we reduce this, divide by 2. Okay, I don't think 131 and 352 share a common factor. So there's our reduced fraction. So as a decimal, this is going to be equal to 0.372. And I'm going to give 3 decimal places because in baseball, typically, this is called the batting percentage, and this is given with three decimal places. As a percentage, we can easily convert this to a percentage. So 37.2% means that he got a hit 37.2% of the time, which is quite good in baseball.